If a neutron star feels impossible because matter is crushed almost beyond recognition, a black hole feels impossible because space itself seems to give way. The common image is dramatic, a bottomless cosmic drain swallowing anything nearby. But the real science is both calmer and more astonishing. A black hole is not a magical vacuum cleaner. If the sun could somehow be replaced by a black hole with the same mass, Earth would not suddenly spiral inward. It would continue orbiting the same mass, though the loss of sunlight would be catastrophic for life. Gravity depends on mass and distance. The difference is that a black hole packs enough mass into a small enough region that there is a boundary around it, called the event horizon. Cross that boundary. An escape is no longer possible, not because something grabs you like a claw, but because every possible path forward leads deeper. In even light cannot find a route out. That is why black holes are black. The event horizon is not a solid surface. It is more like a point of no return written into the shape of space-time. Outside that boundary, black holes can be studied like other massive objects. Scientists detect them by watching stars orbit unseen companions, by observing hot gas glowing before it falls in, and by measuring gravitational waves from black hole mergers. In recent years, radio telescope networks have also produced images of the glowing material around the horizons of supermassive black holes. Those images do not show the inside. They show the shadow and surrounding light, shaped by extreme gravity. What is known is already remarkable. Black holes range from stellar mass objects formed after the deaths of massive stars to supermassive black holes found in the centers of many galaxies. They influence how gas moves, how stars form nearby, and how galaxies evolve over cosmic time. What remains uncertain is just as fascinating. Scientists still do not know exactly what happens at the singularity predicted by general relativity, where the mathematics suggest density becomes infinite. Many physicists think that a deeper theory, one that combines gravity with quantum physics, is needed to describe the true interior. So, the honest answer is not that black holes are fully understood. It is that their outer behavior is strongly supported by evidence, while their deepest nature remains one of physics' greatest open questions. The lesson is that the universe does not need fantasy to be strange. Follow gravity far enough, and even space becomes part of the story. And that brings us to a quieter, kind of impossible object, a planet with no star.